March 28, 1979, 3:58 a.m. As it has for eons, the Susquehanna River continues this night on its ancient way through southeastern Pennsylvania, sleeping now across the river from the blinking lights of 4 30-story towers. These enormous monoliths mark the site of the 3 Mile Island nuclear power plant. Perched on a sandbar in the river, the plant swills tons of the Susquehanna's cool water every hour. The water absorbs the enormous heat produced by 150 tons of uranium that lie buried in the heart of the plant's 2 nuclear reactors. In boilers 7 stories high, still other pipes carrying more water absorb this heat and turn it into 250,000 pounds of pressurized steam a minute. The tremendous energy now trapped in this superheated steam moves on to a 500-ton turbine as long as a city block. The turbine uses the steam's energy to spin a generator that at last produces the final product of this very complicated process. Almost 1 billion watts of electricity. Once it has done its job, the steam transfers its scalding temperature off to more water, which in turn finally loses its heat, trickling down the giant cooling towers. 3 men are on duty this night inside the control room of Unit 2, one of the plant's 2 generating units. They are responsible for over 1,000 gauges, lights, meters, and switches that monitor the health of Unit 2. Tonight, repairs are being carried out. Workers are shooting compressed air into a pipe, trying to unclog a filter. They have done this before, but this time, things will be different.
4 a.m., what Ray Bradbury called the low ebb of the soul. Late at night, often the time when accidents happen.
Using compressed air to clean a filter is a routine maintenance technique. But tonight, a trace of water has worked its way back into the air system, and in an instant, the great machine senses its presence. Nothing at 3 Mile Island will ever again be routine.
Suddenly alarms started going off, lights flashing. One person described the control board as lighting up like a Christmas tree. They didn't know what happened. They couldn't figure it out.
The plant's computers react as though the water in the air system is a dangerous invader. Water in the line can lower critical air pressure to valves and pumps. The computers fight back by instantly shutting down those pumps. But this means that the all-important coolant is no longer relieving the reactor of its tremendous heat.
And that caused the control room operators to face situations that they had never encountered before and had never been covered in their training or in their procedures.
With nowhere to discharge its tremendous heat, the pressure in the primary coolant system within the reactor begins to build. Sensing danger, the computer now orders cadmium rods to plunge into the reactor, shutting down the chain reaction that is splitting millions of atoms. But even with the nuclear reaction turned off, intense heat and enormous pressure continue to increase. The heat and pressure can tear the system apart. A pressure-operated relief valve known as a PORV now opens to vent the pressure. All of this is normal precaution built into the system. What isn't normal is that the valve fails to reclose. It will now threaten this great machine with destruction. Even worse, the PORV valve indicator light on the control console goes out, giving the operators the impression that the valve, having done its job, has now closed. But what the light was designed to do was simply say the control order had been sent. It had been sent, but not obeyed. Reactor coolant is what separates a safe reactor from a nuclear nightmare. Now, that precious coolant is gushing out of the stuck valve without anyone's knowledge.
The experts said, you never have to worry about an accident because we have backups to backups, and there'll never be an accident.
We were assured that an accident like TMI was, quote-unquote, non-credible. It couldn't happen.
But for all the promises of the past, the accident was happening, and happening quickly. Unnoticed high up on the pressurizing tank of Unit 2, 1,000 pounds of radioactive steam and water a minute continued to pour out of the stuck relief valve.
So now there was less and less coolant every minute, and it caused the instruments to go crazy, to lie to the operators.
There are 2,000 instruments in the control room. Amazingly, none show how much coolant is in the reactor. The status of the reactor's all-important coolant is monitored indirectly by measuring the pressure inside the reactor. It's similar to showing how much water is in a tea kettle by measuring the pressure of the steam coming out. And what all these lights and gauges now show is a level of pressure in the system that says water is gradually filling the reactor's pressure tank. If allowed to fill to the top, the water will finally have nowhere to expand and will burst the critical coolant system like an overinflated balloon. Reactor operators call the condition going solid and have been taught never to allow it to happen. The pressure gauges suggest the water is continuing to rise, 200, 300, 350 inches. The manual says 400 inches is the maximum.
That pressurizer was shown to be full of water when in fact it was actually losing water. It was a false indication of where the level was. But they responded in the way their procedures and training had taught them was to deal with that problem.
5 a.m. The control room begins to fill with people all trying to bring the worsening situation under control. But the system is not behaving according to the book. With the pressure so high, there should be too much, not too little water covering the core. Instead, the reactor is getting hotter and hotter. The problem is that no one knows about the coolant gushing out of the valve.
They had their instrument panel, but because of the damage, they began to feel they couldn't trust the readings that they were getting on the instruments.
As the reactor coolant heats up, more of the liquid is turning to steam. The giant pumps that move 2,000 gallons of water a minute are not designed to handle the steam. They start to violently shake and vibrate. If they tear themselves apart, the plant is doomed. An unheard-of decision is made. The control room supervisor will gamble. He orders reactor pumps turned off.
They did exactly the wrong thing, but they thought they had never been trained for this situation. They thought it was a way to keep the reactor from, quote, going solid. So they were fooled. They began letting coolant out.